Hello everyone, so today we are going to be discovering the world of 2D and 3D shapes. I'm Lin Syuen.
I'm Trixie.
I'm Qi Hui.
I'm Jun Kai.
I'm Aidan.
And I'm Yu Zhe.
This is our table of contents. In our presentation, we will include Chapter 10.1 until Chapter 10.7. Chapter 10.1 Points, Lines, and Angles. Chapter 10.2 Parallel Lines, Perpendicular Lines, and Related Angles. Chapter 10.3 Congruent Figures. Chapter 10.4 Line Symmetry. Chapter 10.5 Rotational Symmetry. Chapter 10.6 Polygons and Circles. Chapter 10.7 3D Shape, Plans, and Elevation.
Okay, so the first topic we're presenting today is points, lines, and angles. So points are like dots. It's a primitive notion that models an exact location in space and has no length, width, or thickness. A type of point is a vertex. Like a vertex is like a corner. Like in the polygon here, you can see the corner is called a vertex, and then the figure on the picture on the left, you can see point A and point B. They're like dots lah. Okay, so the next one is lines. So a line has only length but no width and extends in the opposite direction infinitely. So this is a line like this one you can see in the pictures. Multiple straight lines can form relationships such as parallel and perpendicular lines. So two straight lines can combine to form an angle like this. So the last one of this subtopic is angles. So angles consist of these parts, a vertex and two arms. I told you earlier that the vertex is like a corner, like point S, and then there's two lines, which is the line SR and the line ST, which make up the angle. The lines are called arms, and the arm that forms the base of the angle is called the initial side, and the one that the side is measured up to is terminal side. There's some examples here. The first picture, this is a point, and the second picture is a line, and then the third picture is an angle.
So now I'm going to talk about Chapter 10.2 Parallel Lines, Perpendicular Lines, and Related Angles. I will include parallel line and perpendicular line, related angles formed by parallel line, and related angles formed by perpendicular line. Okay, so firstly, parallel line. Parallel lines are lines that never intersect and are same distance apart. There are few characteristics of parallel line. Parallel lines are always in the same plane and never intersect. Parallel lines are same distance apart and have the same slope. The symbol for a parallel line is similar as 11. For the picture given beside, PQ are parallel to RS. There are a few examples of parallel lines in the real life. For example, railroad tracks, zebra crossing on the roads, etc. Next, I'm going to talk about related angles. If two lines which are parallel are intersected by a transversal, it will form three angles, which are corresponding angle, alternate angles, and co-interior angle. So firstly, corresponding angle. A corresponding angle are one of the types of angle that are formed when two parallel lines are intersected by the transversal. As the picture shown, angle 1 are equals to angle 2. And corresponding angle, one of them is at interior and the other is exterior. They are on the same side of the transversal but not at the same vertex. To find the corresponding angle, you can find the F shape. Next, I'm going to talk about alternate angles. The formation of alternate angles are also same as corresponding angle. Alternate angle don't have the same vertices and fall on the alternate side of the transversal. And alternate angles are equal in measure. If you want to find the alternate angles, look for the Z shape. And there's two pictures shown. One is angle A and one is angle B. For angle A, it is an acute angle and angle B is an obtuse angle, though they are both same of alternate angle. Next, I'm going to talk about co-interior angle. Co-interior angles are also known as consecutive interior angles. They are the two angles that are on the same side of the transversal It forms when two parallel lines are intersected by the transversal. In the picture shown, angle 1 plus angle 4 equals to 180 degree. Angle 2 plus angle 3 equals to 180 degree also. The two interior angles are only equal when they are both 90 degree. They have the sum of 180 degree in a co-interior angle. To find the co-interior angle, look for the C shape. Next, this is an example. This picture shows three of the angle that I have just mentioned. For corresponding angle, there's 4. For alternate angle, there's 2, and there's 2 co-interior angle also. Now I'm going into perpendicular line. Perpendicular lines intersect at 90 degree angle, forming a square corner. The characteristic of a perpendicular line are in the same plane and always intersect. They intersect at 90 degree angle, and the symbol is a upside down T. There are a few examples of perpendicular lines in real life. For example, letter T, door, and the side of a set square. Now, going into the related angles of perpendicular line, there's only one angle that are related with perpendicular line, which is the right angle. A right angle is an angle of exactly 90 degrees. Furthermore, in a right angle, two straight lines are perpendicular to each other at the intersection. A square or rectangle consists of 4 corners with right angle.
Now I will be talking about chapter 10.3, which is congruent figures. Firstly, what are congruent figures? So if two figures can be placed precisely over each other, they are said to be congruent figures. The term congruent, which means equal shape and size. This shape and size should remain equal, even when we flip, turn, or rotate the shapes. The corresponding sides are the same, and the corresponding angles are also the same. So here there are a few examples of congruent figures. As we can see, the blue shape is congruent to the yellow shape. Here are a few examples of congruent figures. Let's look at the first example here. We can see that these two quadrilaterals are congruent to each other. You can see that the red shape has been reflected to give the blue shape here. And now for the second example, you can clearly see that these two polygons are congruent because they are in the exact same size and shape. For the third one here, these two polygons are also congruent. The red shape has been rotated to give the blue shape. So they are still congruent because they are in the same size. Now for the last example, these two polygons are not congruent. They are similar figures. This is because the red shape has been enlarged by multiplying by a scale factor to give the blue shape. Hence, they are not congruent figures because they are not of the same size. Now, we are going to talk about the symbol of congruent. Congruence is represented by the symbol here. Since congruence in objects implies equal shape and size, the symbol of congruence is made of two symbols, one above the other. So on the top, there is a symbol of tilde, which represents similarity in shape. The equal sign here represents equality in size. Hence, congruence is represented by the symbol you can see here, which is the symbol combined of the symbol of tilde and equality in size. Now, if two objects A and B are congruent to each other, we will write it like shown here, which shows that A is congruent to B. Now, there are a few steps to recognize congruent shapes. Firstly, we need to check the type of 2D shape. Then we check the type of corresponding angles and also the corresponding sides of the shape. And lastly, we state if the shapes are congruent or not. This is one of the examples. As we can see here, there is a picture and there are two shapes shown in the picture. So are these 2D shapes congruent? As mentioned before, firstly, we need to check the type of 2D shape. You can see that both of the shapes are rectangles. Then we check the corresponding angle and the corresponding sides. We can also see that all of the angles are exactly 90 degrees. The short sides on both rectangles are 1, and the long sides on both rectangles are 3. So lastly, we state if the shapes are congruent or not. So we can see that these two shapes are congruent shapes because they are of the same shape and the same size. Now let's look at the second example. We can see that there are another two shapes here. Are these 2D shapes congruent? Now, as said before, firstly, we need to check the type of 2D shape. We can clearly see that both of the shapes are rectangles. And now, secondly, we check the corresponding angle and the corresponding sides. All of the angles in both of the shapes are 90 degrees. And we can see that the short sides on both rectangles are 2. But for the long sides, they are different, as we can see on the pink rectangle. The long side is 4, but on the blue rectangle, it's 3. So these shapes are not congruent shapes because they are of different sides.
The fourth topic is line symmetry. The line of symmetry is the line that divides the shapes of an object into two equal and symmetrical parts. Rectangle, for example, there's two lines of symmetry because you can divide the shape into two using two methods. It's also called the axis of symmetry or the mirror line because it looks like the mirrored reflections of each other. The number of symmetrical lines in a shape or figure varies and depends on the type of shape. So like some shapes has no lines of symmetry and some has like a lot. Fun fact, a circle has an infinite number of symmetrical lines. These are line symmetry of polygons. The number of lines of symmetry in a regular polygon is equal to the number of sides of the regular polygon. So when someone says like how many lines of symmetry does a square have, you say 4 because there's 4 sides. And if they ask pentagon, then it's 5 lines of symmetry because there's 5 sides.
Okay, so now I'll be diving into the chapter Rotational Symmetry. The chapter includes Introduction to Rotational Symmetry, Reference of Rotational Symmetry, and Rotational Symmetry of Polygons. Rotational symmetry is when an object is rotated on its own axis. The shape of the object looks the same as the original. The order of rotational symmetry is the number of times an object matches its original outline or original shape in a full rotation, which is 360 degrees. Many geometrical shapes appear to be symmetrical when they are rotated 180 degrees or with some angles clockwise or anti-clockwise. For example, the plus sign, when turned 90 degrees, it's identical to its original image. So it consists of a rotational symmetry, whereas the arrow sign, as it's turned 90 degrees, it's facing downwards instead of sideways. So it doesn't resemble the original image. Therefore, it doesn't have a rotational symmetry. Some more reference for rotational symmetry. As you can see in the image here, as the square turns 90 degrees, it will look identical to the first one, so as the turn of another 90 degrees, and another one, and another one, reaching its final state. So it has order of 4 rotational symmetry. Because the order of rotation in geometry indicates how many times a shape can be rotated 360 degrees while maintaining its original appearance. For example, here, the star can be rotated 90 degrees and look the same as the original. And for the butterfly, after it turns of 90 degrees, it doesn't look identical to the first image. So as another turn of 90 degrees and another one. So therefore, it has no rotational symmetry. Rotational symmetry of polygons. Square, it has a rotational symmetry of 4. And rectangle has an order of 2. Rhombus has an order of 2. height with an order of 1, parallelogram with an order of 2, equilateral triangle with an order of 3, isosceles trapezium with an order of 1, and a hexagon with an order of 6. To know all of this, you can try turning the shapes to find out if this information here are true.
And now I'm going to be talking about chapter 10.6, Polygons and Circles. In this chapter, I'll be covering types of polygons and its properties, circles, and parts of circles. What is a polygon? A polygon is a shape which all the sides are the same and also with the same length. There are many types of polygons, and their characteristics are they have a fixed external angle, which is 360 degrees, and all the interior angles are fixed. For example, for the quadrilateral, which we also call it as a square, has a 90 degree of interior angles. One of the interior angles are 90 degree, and for pentagon, one of the interior angles are 108 degrees. And here are the characteristics of the polygons. For this triangle, or we also call it as an equilateral triangle in this case, has the least number of sides, which is 3 sides. And each of the interior angle have a 60 degrees, which is also considered as an acute angle. The sum of all interior angles are 180 degrees. Next, for quadrilateral, it has 4 equal sides, and each of its interior angles have a 90 degree, and the sum of all of the interior angles are 360 degrees. And for pentagon, it has 5 equal sides, 5 vertices, and 5 interior angles. Each of its interior angles have 108 degree, and the sum of all interior angles are 540 degrees. And for hexagon, it has 6 equal sides, 6 vertices, and 6 interior angles. Each of its interior angles are 120 degrees, and the sum of all interior angles are 720 degrees. And for heptagon, it has 7 equal sides, 7 vertices, and 7 interior angles. Each of the interior angles have 128.57 degree, and the sum of all interior angles are 900 degree. And for octagon, it has 8 equal sides, 8 vertices, and 8 interior angles. Each of the interior angles have a 135 degree, and the sum of all interior angles are 1080 degree. And for nonagon, it has 9 equal sides, 9 vertices, and 9 interior angles. Each of the interior angles consists of 140 degree, and the sum of all interior angles are 1260 degrees. Lastly, for decagon, it has 10 equal sides, 10 vertices, and 10 interior angles. Each of the interior angles have a 144 degree, and the sum of all of it is 1440 degree. And now, I'm going to talk about circles. What is a circle? A circle is a round shaped figure that has no corners or edges, not like polygons. And there are many parts of a circle. Firstly, it's the center, which is like the center of the circle. And the second one is radius, is the constant distance from its center. And now, for diameter, is a chord passing through the center of a circle, which are shown on the picture above. And arc is just like a small and big triangle, or a big and small slice of pizza, as you can see here. Minor arc A and B, major arc A and B. And for segment, is a line that doesn't passes through the center of the circle, as you can see on the picture above. And lastly, for tangent to a circle, is a line that touches the circle at a single point, which is also just like a line stick to a circle. And lastly is sector. A sector is the space inside the section of the circle created by two lines which connects the center. As shown above, it has major sector and minor sector. Usually, the major sector has more than 180 degrees and minor sector has less than 180 degrees.
So lastly, I will be covering the last chapter, 3D shapes, plans, and elevation. In this topic, I will briefly cover the introduction to 3D shapes, different types of view perspective, drawing plan and elevation, and constructing a 3D object. So firstly, 3D shapes are objects that have 3 dimensions, which is length, width, and height. All 3D shapes are solid, not like an 2D shape which only appears on a surface. Plan and elevation. So firstly, plan view. Plan view basically means having a top-down view on an object. It shows us the layout of the object and gives us an horizontal projection. As shown in the picture, the plan view will be 2 yellow boxes. Next, elevation view. Elevation view offers a front-facing view of an object or structure. It helps us to understand external aspects of an object. So there's front elevation and side elevation. Front elevation basically means front view, and side elevation basically means the side view. So as you can see in the picture, the front elevation is an L shape while the side elevation is 2 boxes. Next, drawing, plan, and elevation. So firstly, we need to identify the plan view, front and side elevation. Now there's a tip. So remember that the front and side elevation follows the plan view's direction. So if the plan view is here, the front view will be here, which is the down part of the plan view, and then the side elevation usually will be at the right part. Later I will go more into this. So this would be the plan view, front elevation, and side elevation for this 3D object. Okay, so now I'll be talking about constructing a 3D object. So the first step, we need to observe the plan view. From the plan view, we will know that the object has an L shape. So, as I said just now, the front elevation would be here, side elevation would be here. So through the front elevation and side elevation picture, we can imagine the 3D object. So from the front elevation, we can know that the 3D shape is a 3-block high and 2-block wide shape. And then we can confirm the information with the side elevation. The 3D shape is a 3-block high shape. So this would be the shape. The plan view would be up here. The front elevation would be here, and the side elevation would be here. This will be the end of our presentation. So thank you everyone for listening, and we'll see you next time. Bye.
Bye.